Review unit number 2. There's a couple of big ideas. Unit 2 is about linear equations, so we need to understand what slope-intercept form is. We need to know what point-slope form is. And we need to know what standard form is. Point-slope form is y equals mx plus b. Point-slope form is y minus y1 equals the slope times x minus x1. And x1 and y1 are the point that we're going to substitute into the formula. Standard form, there are 3 rules here. The x and y need to be on the left side. The coefficient on the x cannot be negative, and there can't be any fractions. If you make sure those 3 things are done, then you'll be in standard form. The one thing we need to know is we need to know the slope formula. And that's about it. Now we're also going to be graphing some inequalities, so we'll talk about that when we do those problems. First of all, we want to graph 3y equals 2x minus 6. So to do this, we want to put it in slope-intercept form. To do that, we want to divide both sides by 3 to get y all by itself. Now that we got it in slope-intercept form, we can graph. It hits the y-axis at -2. And then we want to count our slope, which is up 2 and over 3. So after we do that, we want to go ahead and draw a line through those 2 points. And that would be the graph of our line. Problem number 2. Now we're going to graph an inequality. You have to remember here that whenever we're given a linear equation or inequality and there's no x, it means that this is going to be a horizontal line. And this horizontal line is going to be at -4. Because our inequality is less than or equal to, it means at -4 it's going to be a solid line. And since its y is less than or equal to -4, it means we want to shade below the line. So you would want to look for a graph that represents this if you were doing a multiple choice test. Number 4, we want to write an equation in standard form, so we got to follow the 3 rules that we wrote on the first page. They gave me that the slope is equal to 3/7 and a point is 14/15. So because I have a slope and a point, I need to start off by using point-slope form. Substitute the information they gave us. y1 is 15. x1 is 14. Distribute in your 3/7. (3/7) times -14 is -6. Then I would go ahead and add 15 to both sides. Then I would go ahead and you could do 2 things. You can either clear your fractions now, which is fairly easy. If we clear our fractions, we multiply by the LCD, which is 7. So we get 7y is equal to 3x plus 63 because we distribute in the 7. Then we would want to subtract 3x from both sides. We would get -3x plus 7y is equal to 63. But remember, for standard form, we want x and y on the same side. We did that. We want to clear our fractions, which we also did on the last step. But we don't want there to be a negative coefficient on the x, so we need to multiply everything by -1. When we do that, we get 3x minus 7y is equal to negative 63. So we've met all the criteria for standard form. We've taken a slope and a point, plugged it into point slope, manipulated our form to get it into standard form. Number 7. Again, we want to write something in standard form, so we have to follow those rules, but this time they give us 2 points. They give us the x-intercept. The x-intercept, you got to think about that as a point. It's 4, 0. The y-intercept is 0, 6. So I understand that in the question they just said 4 and 6, but you need to know that that is a point on a coordinate plane. So it's an ordered pair. Now that I have 2 points, I need to find the slope. y2 minus y1 over x2 minus x1. Substitute in your information. 6 minus 0 over 0 minus 4. And when you reduce, you get that the slope is equal to negative 3 halves. So I have my negative 3 halves. I just need to take one of my points. I'm going to go ahead and take the x-intercept, which is 4, 0. Now that I have a slope and a point, I do exactly what I did on the last standard form problem. I plug it into my point slope form. Oops. It would be x minus 4. Then I would go ahead and distribute in the negative 3 halves. Negative 3 halves times negative 4 is going to be positive 6. Now at this point I can go ahead and take that equation and I can get rid of my fractions, so I multiply both sides by 2. So I get 2y is equal to, when I distribute in the 2 on the right side, I get negative 3x plus 12. Then I would add 3x to both sides. As you can see, I took my 2 points, I found out what a slope was, I took my slope and one of the points that they gave me, it didn't matter which one, you could have chosen the y-intercept. Then I go ahead and plug it into my point slope, distribute in my slope, manipulate it so that I don't have fractions. I multiplied by 2 to get rid of the fractions, and then I made sure that my x wasn't negative. So I'm in standard form. That is your answer. Number 9, we want to graph some inequalities. There's several ways you can do this. For this first equation, equation 1, you could find the x-intercept by letting y equal 0 and then solving for x. Then you can find the y-intercept by letting x equal 0 and solving for y. But for some of you, it might be easier to take that first equation and solve for y. Put it in slope-intercept form. So to do that, I subtract x from both sides. And then I multiply both sides by 2 to get rid of the 1/2. So I get y is less than or equal to negative 2x plus 6. Now that I'm in slope-intercept form, it might be easier to graph. My y-intercept is at positive 6. And then my slope is negative 2, which is the same as negative 2 over 1. So I'd want to go down 2 and right 1. That puts me at 1, 4. Now, think about your inequality. It says less than or equal to, so my line's going to be solid because of the equal part. And since it says y is less than or equal to negative 2x plus 6, I'd want to shade below. So underneath the line, I'd want to shade. Another way to do this, or to figure out what side to graph, traditionally we can use the origin. Since the origin is 0, 0, what we want to do is plug that into our equation. I'm going to go ahead and show you the other way. So we let y equal 0, and then we let x equal 0, and then we simplify. So it says 0 is less than or equal to 6. Since this statement is true, it also means that we should shade the side of the line that has the origin on it. If we were to get a false statement, then we would have wanted to shade the other side. So I've shaded my first equation. Now I want to go ahead and shade equation number 2. So equation number 2 is x is greater than or equal to negative 2. Anytime you just have an x, you need to know that this means that it's going to be a vertical line. This vertical line is going to be at -2. So I go ahead and draw that line at -2. It's solid because it's a greater than or equal to. And since I want all the x's that are greater than -2, that means I'd want to shade to the right. So the solutions area is going to be the area that's overlapping. So this area here that I have shaded is the solution set. That's what the graph is that we'd want to look for on a multiple choice test. Problem number 11. Again, we have an idea where it just has an x, there's no y, so we need to know that means it's a vertical line. That vertical line is going to be at 2, but since my inequality is a strictly less than, it's not less than or equal to, that means at +2, I'm going to want to make sure that it is a dashed line. And then since it says less than 2, that means I'd want to shade to the left. So dashed line at x is 2 and shade to the left. Now I want to go ahead and graph that second equation. Now since there's no x, it's just a y, that means this one's going to be horizontal. The horizontal line is going to be at y is equal to 5. And because it's a less than or equal to, it's not going to be a dashed line, it should be a solid line. And y is less than 5 means I'd want to shade below. And so, because we're looking for the overlapping part, the shade that I'm highlighting right now in yellow would be the overlapping part. Number 12, determine if these lines below are parallel, perpendicular, or neither. So for parallel, if the slope of line 1 is equal to the slope of line 2, then that means they're parallel. For perpendicular, if I multiply the two slopes and it's equal to -1, or opposite and reciprocal, then that means they're perpendicular. So to figure out what the slope is, I have to solve for y. So take equation 1, solve for y. To do that, I subtract 4x from both sides. That one was pretty straightforward. Now take the second equation, do some work with that, get y by itself. I add x to both sides. And then I divide both sides by 4. So here are my two equations in slope-intercept form. Slope 1 is equal to -4, and slope 2 is equal to +1/4. So they're obviously not parallel because they're not equal to each other. But if I multiplied these two numbers, it would equal -1. The other thing you can recognize is that one of them is positive and one of them is negative, so that's the opposite idea. And 4 and 1/4 are reciprocals of each other, so they are opposite reciprocals. So these two lines are perpendicular. Number 15, write an equation in standard form. So we've already done this twice. This time they want us to be parallel to the line they gave us, y equals 4x plus 1, and we have to make sure that this point, we pass through that point, 2, 3. So the big idea here is that if we're going to be parallel, we have to have the same slope. So I need to use a slope of 4, and I have to use this point. So what do we use when we have a point and a slope? We use point-slope form. Substitute in the information provided. Distribute in the 4. And then add 3 to both sides. So, oops, we're not done yet. What we need to do now is get the x and y on one side because we want to get in standard form. So I'm going to go ahead and subtract 4x from both sides. We're not supposed to have any fractions, which we don't. So we're good there, but we're not supposed to have a negative coefficient on the x. So to get rid of that negative 4, we multiply both sides by negative 1. So distributing the negative 1, we get positive 4x minus y is equal to positive 5. So we took the slope that's parallel, which is 4, and we took the point they gave us, we plugged it into point slope, and we manipulated our equation to get into standard form. X and y on the left side, no fractions, and the coefficient on the x cannot be negative. Solve for x and y. Here we have two systems, so we're going to do elimination method. What we want to do is either get rid of the x or get rid of the y. Since one of my y's is positive and one of them is negative, that's what I'm going to work on. I'm going to take my first equation and multiply both sides by 2. And then I'm going to take my second equation and multiply both sides by 5. When I do that to the first equation, I get 16x plus 10y is equal to negative 26. The second equation becomes 15x minus 10y is equal to negative 5. As you can see, the reason I multiplied the first one by 2 and the second one by 5 is because now the y's will eliminate. Divide both sides by 31, and you get x is equal to negative 1. Now take one of the equations, it doesn't matter which one, and substitute in a negative 1. So I'm going to do that to the second equation. 3 times x, which is 3 times negative 1, minus 2y is equal to negative 1. So negative 3 is equal to negative 1. Add 3 to both sides. Divide both sides by negative 2. So the solution to x and y is negative 1 and negative 1. Number 19, solve for x, y, and z. So it's a system of 3 variables. Now, what we need to recognize is that this last equation just has 2x equals 10, so it should be easy to solve for x right away. To do that, we divide both sides by 2, and x is equal to 5. So I'm going to write that over here to the side. Now that I know what x is, I should be aware that I could plug that right into the second equation. 5 times x minus 4z is equal to negative 3. Subtract 25 from both sides, and divide both sides by negative 4. Now I have x and z solved for. I can take those two values and plug it into the first equation. So x is equal to 5, y is equal to negative 3, and z is equal to 7. 21, this one is a word problem, but it is a systems of equations. We need to write our system, so it's going to be 3h plus 2c, right? I'm going to use h for hamburgers and c for Coke. Should equal $8.70. Then 2 hamburgers plus 1 Coke is equal to $5.40. Since it's asking me to find 1 hamburger, I'm going to eliminate the Cokes. To do that, I'm going to multiply the second equation by a negative 2. When I do that, my first equation stays the same. My second equation becomes negative 4h minus 2c equals negative 10.8. Now I would go ahead and add those up. As you can see, the c's eliminate. And I get negative h is equal to negative 2.1. Multiply both sides by a negative 1. And you get that 1 hamburger is equal to $2.10. 23, a warehouse of 30 bins. Some hold 20 pounds of apples, some hold 15 pounds. How many of each type of bin is needed to hold 510? Well, you can use any variables you want, but since one of them holds 20 pounds, I'm going to think of that as the large bin. And the one with 15 pounds, I'm going to use S and think of it as a small bin. And so the idea is if I add the large bins and the small bins, I'm supposed to have 30 of them. Now I'm going to go ahead and use the pounds that each hold. The large one holds 20, the small one holds 15, and the total pounds we want it to hold is 510. So there's our systems of equations. I can go ahead and eliminate either the L or the S. I'm going to eliminate the L's first by multiplying the first equation by negative 20. The second equation stays the same. The large bins eliminate, and I'm left with negative 5s is equal to negative 90. And so the small bins, after I've solved for s, is equal to 18. Now that I know that the small is equal to 18, I take the first equation and I substitute in 18 for s. Subtract 18 from both sides. And you get the large bins are 12. So there are 18 small bins and 12 large bins.